Okay, students, we're going to go over some old DCAS problems that deal with circles. These are what you can expect to see on the DCAS. Okay, circles is big, as I've told you. All right, so we have an equation of a circle here. What's the x-coordinate of the center? We only want the x-coordinate, not both. So remember, we arrange it so the x's are together, put plus blank. Okay, notice I'm not even dealing with the y or the radius part over there because I only want the x. Remember, I do half of b, quantity squared right here. So that is -3 squared, puts it as 9. Remember, so that would factor into x minus 3 quantity squared. Okay, that part just comes right there. And then remember, I take the opposite sign. So that'd be a +3 for my answer. All right, next. Circle P is graph in the coordinate plane with center. Circle P contains the point 4,6. What is the equation of circle P? So we know the center's already there, so we can already fill it in. 2, 3. Remember, this is r squared every time. And from the center to a point of the circle is r. So if we find that distance, there's what we're looking for, r squared. So how far from 2 to 4? That's 2. I'm going to square it. How far is it from 3 to 6? That's 3, and I'm going to square it. And that equals r squared. Remember, to find r, we would take the square root of both sides, but we want r squared. So what is 9 plus 4? 13. R squared is 13. 13 goes right there. That's simple. Okay, part B. Circle Q is defined by this, so it means our center is 0, 0. And we have a radius, remember it's the square root of that, 4. It's graphed in the same coordinate plane as circle P. So circle P came from above, right here. Okay, so remember that was at 2, 3. So this is circle P, this is Q. That centers that, and the radius there, it was square root of 13. Okay. Select the circle. The center for circle Q is above or below. 0, 0 is below. And to the what? 0, 0 is below and to the left. Oops, left of circle P. Obviously, you have 2, 3 right here for that center and 0, 0 for that center. Below and to the left. The radius of Q, square root of 13, is less than, right? And the square root of 16 is less than the radius of circle P. Oh, no, circle Q right here. That radius is greater. So it'll be greater than circle P. Okay, next. We have a circle with a chord BD. Remember, BD, that chord, happens to be the longest chord because it goes through the center, which is called the diameter. Don't forget that. The longest chord of a circle is the diameter. The measuring angle AOD. Well, first off, we want to mark everything we know. These are all radii, so we want to mark that up first. Second, I want to put a right angle symbol right there because I know it goes to the ends of the diameter, which means it's half of the 180, 90 degrees. Put down the information you know first. Okay, well then, what do I know from there? Then I know that angle, isosceles triangle, so base angle is congruent. And it's got to be the exact same as that one because I have another isosceles triangle there. So since these are congruent, these have to be 45s. Okay. Let's hold on just a second right there. Let's put that right there. Okay. Not drawn to scale. Okay. Oh, angle AOD is 50 degrees. Okay. So angle AOD is 50, which means I have 130 left. I divide that by 2 for my isosceles. It was by 2, and I get 65 degrees. So each of these is 65 degrees. And remember, this is a right angle that makes this 25 degrees, which makes this 25 degrees. Okay. And so it says, which angles must have a measure of 25 degrees? These two right over here. So what are those angles? Select all that apply. Angle OBA or ABO. What was that called again? We have ABO, ABO. Okay, another one we have is BAO, BAO. There's one. The other one, that's BAO right there. And OBA. Okay, so we can call it OBA, which is same as ABO. That's our other one. So there's only that one right there. Okay. All right. For each triangle on the table, use the given information to figure the identity of the triangle must be isosceles or right. So we've already identified that ourselves. So angle or triangle ABD. ABD, the big one, we know is a right triangle. AOD, AOD, and ABO are both isosceles. Okay, next. Okay, the inner part of the circle of the logo is a circle with a radius of r inches. So here's that circle right there of r inches, radius r inches. The logo has a border that is concentric. That means same, co means same center. So it has the exact same center as the outer circle. Surrounding the inner circle, the area of the border is 14.5 square inches. This area, just the border, is 14.5 square inches. The logo is shown. Okay. Write an expression that represents the total area in square inches of the logo in terms of the radius r of the inner part of the logo. If the total area of the logo is 127 square inches, what's the approximate value of r? So we have area is pi r squared. It tells me it's approximately 127 square inches. Okay, so I'm going to divide by pi, and then I have to take the square root. Okay, to get r. So this is the approximate value. So we're going to round it and show you where to explain your answer. Okay. If the total area of the logo is 127, companies design a circular logo, the inner part of the logo. Oh, the total area of the logo. Okay, so that's the inside plus the outside. Well, so we know. Okay, so I thought the total area was just the inside. It's the whole thing. Okay, so the total is 127. We know the outside border part is 14.5. So we subtract that. It's 113, 112.5. So 112.5. So we're changing this to 112.5 for the inner one. And now we put that in the calculator. Graphing calculator. Okay. Square root of 112.5 divided by pi. Go outside the radical. 5.98. Okay. So 5.98 r is approximately 5.98. They might want you to say 6. Okay, didn't say around the nearest whole number. What's the nearest whole number is 6. Okay, and whatever the units are, square inches, so it's therefore inches. Hopefully square inches, that's area. The radius itself is 5.98 inches. Okay, all right, next. The area of a sector. So you gotta remember the area of a sector formula is x over 360 area, so pi r squared. The area of a sector. The sector of a circle has an area of 104 pi divided by 9 square inches, and a central angle with a measure of 65 degrees, or that's where the central angle or the arc measure, same thing. What's the radius of the circle? So we now solve for r. Okay, so here we can say that pi cancels. Okay, we have 65 over 360. So you can multiply by the reciprocal, which would be 360 over 65. That will cancel this out from this side. So I have r squared equals that. So it wants the radius. So now I'm going to take the square root of that whole thing right there. So what I'm doing there, you see, is I'm doing 104 times 360 divided by 9 times 65. Okay. If I'm going to put all this in one square root, I need to have parentheses around the whole numerator and parentheses around the whole denominator. If I'm going to leave it on one radical in the calculator. Or else you can just do 104 times 360, get that answer, divide by 9, whatever 9 times 65 is, get that answer. Okay, but I'll put it all as 1. Okay, so we have the square root in parentheses 104 times, what was it again? 360 divided by 9 times 65 divided by parentheses 9 times 65 parentheses, go outside of that, 8. Oh, it came out perfect. So the radius is 8. And there we see that answer right there. Guaranteed on here. Guaranteed. Sector. Okay, you got to have that formula memorized. Guaranteed to have one problem on that. No question. Just as you're guaranteed to have 2 problems dealing with equations like this with the circle in standard form and solving it. The point 3, negative 6 is an endpoint of the diameter of a circle. So it's a point on the circle. Okay. So first we're going to get the center of the radius by grouping the x's together. Minus 6x plus blank plus y squared plus 2y plus blank equals 15 plus blank. So it's half of b, which is negative 3 squared, which is 9. I'll change the color so you know I'm adding to it. Wasn't the original problem. Half of 2 is 1 squared is 1. So I added 10 to the left, so I must add 10 to the right. This factors in into x minus 3. Remember, I can just drop this down. Quantity squared plus y plus 1. Quantity squared equals 25. Just drop that down. So my center is 3, negative 1. My radius is 5. Okay. So it says, what's the y coordinate of the other endpoint of this diameter? Okay. So this says 3, negative 6 is an endpoint. The center is 3, negative 1. Endpoint, center, that's endpoint 1, endpoint 2. Okay. Notice the x's don't change. I say how far is it from 3 to 3? That's 0, so I'm going 0 this direction. So it stays at 3. How far would I do to get negative 6 to negative 1? I went plus 5, so I must plus 5 again. And so it's negative 1 plus 5, 4. And remember, we want the y coordinate, 4. Pay attention, they only want the y coordinate. If they're smart, they would put a 3 in there to see if you pick the x coordinate. Okay. So again, multiple steps. First, complete and squared, come up with the center of the radius, and then using that with, I did it just like this. You could have graphed it out and done slope from the endpoint to the center. How do I get from there? Slope down and right, for example, or whatever, and then do the exact same thing one more time, and I'll take you to the other endpoint. All right, here we have an equation again. Select from the drop down menu. So obviously they're telling you it's plus y squared because there's no other y with it. So we know it's going to be x minus 4 quantity squared. So I should be choosing x minus 4 quantity squared plus y squared. Okay, I don't know what this choose was here. All right, next one here. Triangle BCD. Okay, first off, we know it's a right triangle because it goes the endpoints of the diameter, half of 180. That's your 180. Half of 180 is 90. Remember, it's an inscribed angle there. If that's 10, we know that's 10 because they're both radii. Okay, so all radii are congruent. That's also 10. That's another radii. Okay, so we have isosceles triangles there. Okay, just remember that. We want to always identify what we know to begin with and go back and read the question. Inscribed angle says PC is 10. We've already got let the measured angle CBD, this angle right here, be X. So that makes this X. And the measured angle BCD, the whole thing here, that's X plus 54. Well, we know that whole thing is 90 degrees. Angle BCD equals 90. So now we can solve for X. Subtract the 54 across, and I get 36 degrees. So X is 36. Okay, but now, so find the value of X. We just did that, 36. Select from the drop. So don't forget, if that's 36, then the other one has to be 54 right here, because I have to add. So that's 36. That's 36. So that's 72. So that makes this 108. And that's a linear pair, which makes that 72, which makes that 72. No. We already know that's 54. This is 54. Base angles are congruent. Okay, right there. It's also a triangle. Select from the drop down menu to correctly complete. So it's the length of segment CD. Okay. Is blank because blank. Okay. Well, we do know, since this is the hypotenuse, that the length in that hypotenuse is 20. Okay. So here I'm going to redraw this out here, the big the triangle again. So we know this is 20. We know it's 90. We know this is 36. So we can use SOHCAHTOA to find the length of CD, right? I'm using the 36. I could have also used the 54. This is 54, so I could use either angle, okay, to find the length of CD. Now it's SOHCAHTOA. So if I'm going to go ahead and use the 36, then this is the opposite side, and there's my hypotenuse, always across from the right angle. There's my adjacent. So I want CD. So O over H, which is sine. So the sine of 36 equals X over the hypotenuse 20. So X equals 20 sine 36. That's the exact answer. It says the length of C is blank because blank. Okay, they probably have you choose a sine function in there as well. Okay, so now you can figure out that length. Okay, and there you go. Okay, the figure shows a circle in the coordinate plane. The center of the circle is point H comma K. Point B is X comma Y. On the circle, triangle ABC is a right triangle. Tell me that. So I can use Pythagorean theorem to set it up. So notice this distance is X minus H, and this distance is Y minus K. Subtracting the Y coordinate and the X coordinates. So notice when I put Pythagorean theorem together, I get X minus H quantity squared plus Y minus K quantity squared equals R squared, doing the Pythagorean theorem, and that is your standard form of a circle. There you go, right there. Okay. So The variables h can be used to write the absolute value expression for the lengths of the legs. Okay, so the length, we subtract the, it'd be x minus h for the AC, x minus h, absolute value, doesn't matter which way you go h minus k, but it's absolute value, positive distance is always positive. BC is the change in y, which is y minus k, okay, and then part B is to fill it in, which we already have written right there. Now we're just filling that in, x minus h, quantity squared, y minus k, quantity squared equals r squared, the standard form of an equation of a circle. That's why you need to have it memorized, and you already have it right there. You already have known that without even having to graph it. Okay. All right. Here's another type that's commonly missed because they're not used to seeing a B there. Okay. So determine the y coordinate of the center. So first off, we want to complete this square, x squared minus 4x plus blank plus y squared plus 2y, oops, plus, dang it, what just happened there? Plus blank equals b plus blank. Okay, so we know it's negative 2 squared, 4, that's plus 1 squared is 1. We added 5, so we got to add 5 over there. This becomes x minus 2 quantity squared plus y plus 1 quantity squared equals b plus 5. Don't drop off that b. Determine the y coordinate of the center. Well, we know it's opposite, opposite, and the radius equals the square root of whatever b plus 5 is. Okay. Determine the y coordinate. It's negative 1. We actually already had that in there. The radius of the circle is 7. So if the radius is going to be 7, okay, if the radius is 7, that means this right here had to be the square root of 49. Square root of 49 is 7. So now I have b plus 5 equals 49, and so b has to equal 44. And there's my answer. Okay. So their answer is off right there. It's 44. Wherever that came from. 4 plus 1 is 5. Yep. Okay. All right. Here's our inscribed angles. You can half it. Angle CBD. CBD is 44. Well, don't forget that's a radius and that's a radius. So I have an isosceles triangle. Base angles are congruent. First thing I should know. That's 44 and 44. That's 88. 88 from 180 is 92. So that makes the central angle 92, which makes the arc measure 92, which makes this half of it 46. Find the measure of BAC in degrees. We just did it, 46. Okay, so again, you're having to remember isosceles triangle, base angle is congruent. Fill it in. Okay, sum of all triangles 180. Okay, see this over and over. We talk about isosceles triangles a lot. You see it being used multiple times with circles, especially the isosceles triangle. So expect to see that. The semicircles are tangent to each other. Okay, so don't forget that's 90 degrees right there. It's 90 degrees right there. Okay, we know that equals that. We know this equals this. Okay. If PB is 6, that makes this 6. Okay, it makes this 6. That's a radius as well. You know, it's 90. What is ED? Okay. So, we do have overlapping triangles. So these are similar triangles. Okay, because that angle is congruent to that. So we have AA similarity, just so we know that. Okay. We call this X, this X. Okay. Oh, BC also equals 6. TB equals 6 and BC equals 6. Oh, okay, so these are both 6. Oh no, BC itself is 6. So in each of these is 3. Okay. And we don't know what this distance is from here to here, so we'll call that X, because now we do know these distances are 3, so we'll call that one X. Okay. Let's see here. Oh, since this is 3, then this is 3. There's the other key part right there. Okay, so notice our overlapping triangles here. This is a full length side, that's a full length side. So the small triangle to the big triangle is exactly a ratio of 1/2, 1 to 2. Okay, so we do know that ratio is 1 to 2. So here, if we say this full side right here, that is X plus 3. And what is the full length of that side? That'd be X plus 6 plus 6 is 12. X plus 12 right there. Okay. So this took making sure you don't forget any little thing you can put in there, and see that we have overlapping triangles, AA similarity. Remember, our 3 ways of proving triangles similar: AA, SAS, and SSS. Remember, on the S's, the corresponding sides must be proportional or the exact same ratio. The angle measures must be exactly the same. So we have AA similarity here. So now we just cross multiply. Don't forget we put parentheses around this. So I have 2x plus 6 equals x plus 12. Oops, 12. Subtract the x across, subtract the 6 across, x equals 6. So that is 6. Okay. Now, so if I just take that last triangle, I have 3 there, and I have a total of 9 there. Now, to get ED, I have Pythagorean theorem. Oops, I drew it upside down right here. I need to draw it with the right angle in the right spot. There's the right angle. That's 3. The hypotenuse is 9. Okay, across that, and then here's the one we're looking for. We'll call it x here, doesn't matter. So I have x squared plus 9 equals 81. X squared equals 72. Take the square root of both sides. X equals, that's square root of 36 times the square root of 2. Remember, I taught you to take half that number to begin with. This is not a perfect square. It's 36. That is a perfect square. And so the exact answer is 6 root 2. Oh, square root of 72. They went ahead and left it. There's square root of 72 right there. They went ahead and left it as square root of 72. You didn't have to reduce that. That was a tough problem. There was a lot of steps involved in there. We had similar triangles. We had radii being congruent. You had to see overlapping triangles for the similarity. You had to be able, in order to put the x, put in all the numbers correctly. You had to recognize that a full length side there and full length, so I could get the ratio of the smaller triangle, bigger triangle, and then to then solve for this x, and then to use that triangle to use Pythagorean theorem to get my answer. That's probably the toughest one almost you might see. Okay, the circle with center F is divided into sectors. Circle F, E, B is the diameter. The radius of F is 3 units. Okay, drag and drop each arc length to a subtended central angle. Remember, arc length is x over 360 times 2 pi r. You have to have this memorized. It's not given to you. That's why this is a highly missed one. Okay. Okay, we're just talking about degrees here then. Okay, so there's going, all I want to do is change from degrees uh, to radians. Looks like so. Arc length in radians. Oh, the arc length in radians. Okay, so first we need to find out the degrees. AFB. AFB. 120 degrees 120 over 360 times 2 pi, and r is 3. Okay, so we're leaving in terms of pi. Okay, leaving that. So 120 over 360 is 1/3 times 2 pi r. The 3's cancel. So my arc length is 2 pi. So the first one is 2 pi. Boom. BFC. BFC is 45 degrees. So 45 over 360 times 2 pi r, which we already know is 3. 45 goes into 360 8 times. So that's 1/8. Of course, you could just type all this in a calculator and you would leave the pi out. Okay, I can go 45 times 2 is 90, times 3 is 270. 270 out of 360 is 3/4 times 2 pi. And that's going to cancel down to 2, so that's 3 pi over 2. Hold on here. Let me see if I did it wrong here. Let's go this way. 1/8 times 2 pi r. Okay. 4 times 3 pi over 4 is my answer. 3 pi over 4. CFD. Come on. CFD. CFD. 30 degrees now. So now we're just changing this to 30 degrees. 30 degrees is 1/12 times 2 pi r. 3 will cancel 12. 4 times 2 will cancel the 4 twice, so I get pi over 2. Pi over 2 goes there, so therefore pi has to be the last one right there. Okay, so got to know arc length formula. X over 360 times 2 pi r. Fill it in. Guaranteed to be on the DCAS. Whatever these problems were on the DCAS already. Another one of completing a square with the b here. Determine the y-coordinate in the center. Oh, this was the exact same one we did before. Okay, so I'm not going to do that one again. Okay. Okay, the circle center is divided into sectors. In circle F, EB is diameter. The length of FB is 3 units. Select the correct expression that represents the arc length. Again, arc length. X over 360 times 2 pi r. So just like the last one, of AED. So I have to know how many degrees that is and then fill that in. Okay. So we know this is 60 because that's the diameter. We know that's 75, so this must be 105. 75 plus 105 is 180. So that total degrees is 165. So I have 165 over 360 times 2 pi r was 3. Okay, the 3 cancels 360 120 times. 2 cancels the 120 60 times. I can divide each of these by 5. Okay, that goes into 12 times, and this goes into it 33 times. I divide each of those by 3 again, which puts it 11 over 4. So 11 pi over 4. Now, of course, you could have typed all that in a calculator. I'm doing it with my brain, 11 pi over 4, and there's that answer. Remember, when you play in the calculator, you leave pi out of it. Pi stays out of your calculator. You do all the other calculations. Okay, pi is in the answer. All right. What's the radius? Okay, we need to first complete that square. You don't just look at that and say 3. That's a common wrong error. I need to complete the square first. Plus blank, that's negative 4 squared is 16. Plus my y squared, there's no other y, so it's 9 plus 16. So it's x minus 4 quantity squared plus y squared equals 25. So the radius is 5. Okay, common errors is do the square root of 9. Don't do it. In the diagram of circle O below, chords A and B and C and D are parallel. When they're parallel chords, then we know the distance, the degrees between those are congruent. And BD is a diameter, so we have parallel lines cut by a transversal, just so you know that. So we would know that those two angles are congruent. Those are intercepted arcs, which make these 30 degrees because they are inscribed angles. Half of this 60 is 30. Measure of angle AD is 60 degrees. What's the measure of CDB? CDB, we already know it. We just did it right there, 30 degrees. Inscribed angle, half of that 60. Okay. Let's see. The equation of a circle with center at 3, negative 5, and radius 4. Remember, we do opposite. So it's plus 3, it should say, and a minus 5. Plus 3 and a minus 5, that's the only one that's got plus 3, and then radius of 4 makes it 16, because that's r squared. Okay, don't forget, opposite, and then square the radius. All right, here we have a tangent, AB. We know that would be 90 degrees. Not that that has anything to do with the problem, but just to remind yourself. And a secant, ACD, are drawn in a circle. We know what do we do with all tangents? We square them. What do we do with all secants? It's outside times the whole. So the whole is the 4 plus x. Okay. What's the length of CD? So we want to solve for x. So 64 equals 4 times the quantity 4 plus x. Now I could distribute that 4 through there, but it would be smarter to just divide by 4. And I get 16 equals 4 plus x. 4 plus what is 16? X equals 12. Boom. But I could have distributed the 4 and then solved it. I still would have got 12. Which graph represents the circle below? We know it's opposite, and square root. So 5, negative 1, the radius of 3. 1, 2, 3. There we go, right there. Here's my answer, number 1. Okay. None of these others have 5, the radius of 3. 5, negative 1. Okay. Here we have center would be 0, negative 3, opposite, square root r equals the square root of 13. What are the coordinates of the center of the circle and the length of the radius? 0, negative 3, and square root of 13. Okay, see that. Okay, below circles X and Y have 2 tangents drawn to them. Okay, so we know those. If we connected that, that is now like our problem that we had before. Okay, the point of tangent CS. Okay, I could have had it drawn like this as well for these ones down here. That would be the same triangle we had below. The ratio of TA to AC is 1 to 3. So that's x, this is 3x. When we see these ratios, you put the x's behind it. If TS, okay, now, here's another thing you need to remember. Remember, if I go to a tangent from outside the circle to 2 different tangents, these lengths are exactly the same. Don't forget, these are the same, and these 2 are the same. So that's a kite we have there. Okay, so if TS is 24, then this over here is 24. So I have 4x equals 24. So x equals 6. So that's 6 and that's 18. Same thing here, 6 and 18. Find the length of SE. SE would be 18 then. Okay, and the diagrams below, chords CD parallel. So that means these 2 are congruent. Measure of arc AC is 30 degrees. So this has to be 30 degrees. What's the measure of arc CD? So CD, don't forget, this is 180 right there. We have 60 plus the 120 adds to 180. So it's 120. Center and radius of the circle opposite. 3, -3, radius is 6. 3, -3, radius 6, right there, number 1. Okay, which one is this? So -5, 1 is the center. Radius is 1, 2, 3. Radius equals 3. So we should see x plus 5 opposite plus y minus 1 opposite. R squared is 9. So that's what you're looking for. X plus 5 squared, y minus 1 squared equals 9. Number 2. Okay. These are all the different types of circle problems you can see. Okay, so here we have two chords that intersect. So we know this one times this one equals this one times that one. Okay, so it says DE is 2x plus 8. EC is 3. AE is 4x minus 3, and EB is 4. So I have 4 times 4x minus 3 equals 3 times 2x plus 8. Now we just solve it pre-algebra. 16x minus 12 equals 6x plus 24. Smaller to larger side, so I have 10x equals, add the 12 across, 36. So x equals 3.6. Number 2 right there. How many common tangents can be drawn to the two externally tangent circles? 1, 2, and 3 right there. 3. Don't forget that inner one. How many common tangent lines can be drawn to two externally tangent circles? So well, yep, 3. Okay. In the diagram below, circle, we have parallel again. So those are parallel, so that equals that. This is parallel, so this equals this. Okay, which statement must be true? Arc CE is equal to D congruent to DF, yes. AC is congruent to CE, no. AC congruent to DF, no. EF, arc EF is congruent to CD, no. Number 1. Okay, lines of AB is tangent circle O at A. Which type of triangle is always formed when points A, B, and O are connected? Right. You know, tangents are always right triangles. Which equation for the circle in the graph below? So it's centered at the origin. 1, 2, 3, 4 is a radius. X squared plus y squared equals 4 squared, which is 16. 4. We have 2 secants. Okay. AE is 4. AB is 12. DB is 6. So that makes this 6. Okay. What's the length of OC? Okay, OC is a radius. I know I can draw that. Oh no, that's not a tangent. Okay. So we have 2 tangents. So we do a tangent outside times whole. So 6 times 12 in this one equals outside 4 times the whole, which would be 4. If we call it OC, we want OC. Is that right? So if I call each of these x, then the whole length would be 4 plus 2x. Then when I solve for x, I'm actually solving for OC itself. Okay, so now we solve that. 72 equals 16 plus 8x. Subtract the 16 across, 56 equals 8x, so x equals 7. Okay, gotta be getting done here. How many more do I have here? 2 more after this. Okay, it's a long one, but circles is huge. Okay, chords A and D and B and C intersect at E. Okay, which relationship must be true? Okay, There's no that's congruent to that. We know that see triangle CAE DBE angle AC B, this angle right here is going to CBD. CBD. Okay, that must be true. We only know that's true if these chords were congruent. So we don't know that. We don't know they're congruent. So no. I'm saying angle AEC, that angle is congruent. Oh, that triangle. Oh, the whole triangle is similar to BED. We do have this A and that A there. Oh, so that A and this angle right here is half of that arc, and this angle right here is half of the same arc. Okay, so now we have AA similarity, which makes these two also. So they're similar triangles is what we have. Okay, that's what we have right there. All right, write an equation of circle whose diameter AB has endpoints. So we need to find the midpoint formula to find the center of the midpoint. Add the two x's divided by 2, that gives me 0. Add the two y's, that gives me -2 divided by 2 gives me -1. So the center is at 0, -1. That's midpoint formula. Got to know that. Guaranteed to have to use it. Okay, and then here's one of my points on the circle, so I can get my R from doing how far from 0 to 4. That's 4, so I square that. How far from -1 to -4? That's 3. That's a 3, 4, 5 Pythagorean triple. So R's 5 right there. There's our Pythagorean triples. Okay, write the equation. So that's going to be x squared plus y plus 1 squared. Don't forget it's opposite, and then R squared is 25. What's the center and radius? 0, 7. Opposite, opposite, and square root 4. 0, 7, radius 4. Okay, we're getting there. Okay, CE is 10. ED is 6. AE is 4. What's the length of EB? Call it X. So 10 times 6 equals 4 times X. Okay, 60 equals 4X. Divide by 4 on both sides and you get 15. Okay, and here we have measure of angle QT. This arc measure right here is 140 degrees. Measure of angle P is 40. Okay. What's the measure of angle RS? Remember, it's the outside arc or big arc minus smaller arc. RS was called X equals double the angle measure, 80 degrees. Add the X across, subtract the 80 across. 140 minus 80 is 60 degrees. Now don't forget, I could have done 140 minus X divided by 2 equals the angle measure. And then of course the first step to do that is multiply by 2 on both sides to get up to the 80, if you prefer that method. For an equation for the center, or for the equation of the circle, -1, 2 is my center, and the radius is 1, 2, 3, 4, 5, 6. So I have X plus 1 quantity squared plus Y minus 2 quantity squared. And we said it was 6, so it's 36. There's the equation. Okay. How many degrees is the measure of arc dB? Now remember, it's that arc X plus this one divided by 2 equals 58. That's the algebraic expression when I do it, but here I told you the shortcut. 72, how do I get down to 58? Minus 14. So I must minus 14 again. Okay, 58 minus 14 is 44. Okay, so if I was to add 72 plus 44 and divide by 2, I better get 58. So is that true? That's 116 divided by 2 is 58. So I checked that. I just showed you the shortcut method right up there. Okay. But you could have done 72 plus x divided by 2 equals 58 degrees, and then solve that, and you would have got 44. Okay, is that it? Oh, last page. Where's the equation for this circle? 1, 2, 3, 4, 5, 2. Radius is 1, 2, 3, 4. So x minus 5. Oh, you're having to figure out from here. Okay, so they give you the whole thing. Okay, so you have to solve one of these. So you know it's got to be x minus 5. So it has to be a minus 10x here to get that. So now we're down to these two right here. And then it has to be a y plus 2. Well, that's y minus. Oh, and it's not 5 negative 2, it's 5 positive 2. That's why. All right, so x minus and y minus. X minus and y minus. Oh, okay. So they're both there. So it's down to those two. Let's complete it. Add it across. So it's going to be x squared minus 10x plus 25. That was the extra. Y squared minus 4y plus 4. That's the extra. Equals negative 13 plus 29. 29 minus 13 is 16. So it has a radius of 4. And that's the one we want. So it's number 2. 4 would not give us a radius of 4. So I'm saying a different radius. It would have been a radius 10 plus 29 again. So 29 minus 5 is 4. And the square root of 4 is 2. Okay. So I don't remember seeing this one before. Okay. So now it's been on there before, but I haven't seen it myself on anybody's. Okay. Which expression represents the length of arc AB? Again, arc measure x over 360, 2 pi r. Fill it in, 120 degrees. 120 over 360 is 1/3 of 2 pi, and r is 6. 6 divided by 3 is 2. 2 divided by 2 is 1, so it's 1 pi. Okay, so they want you to do this. Leave it in these terms. So we cut it down. All right, so we have 1/3 of 2 pi r, just same thing as 1/3 of 12 pi. We see that 1/3 of 12 pi. We do right there, 4. Okay, so they didn't want us to simplify it all the way. They're seeing if you can reduce it down like this. Okay. Here we have two tangents. RS is 6, ST is 4. RP, the whole length, is 15. What's the length of RQ? And we call that X. Remember, whenever secant is outside times the whole, 6 plus 4 is 10, equals outside the X times the whole, which is 15. So I have 60 equals 15x, so x equals 4. What's the length of RQ? 4. What's the number of, okay, the diagonal measure of arc ABC is 268 degrees. So I subtract that from 360, and I get, let's see, 100 minus 8 is 92 degrees right there, and half of 92 is 46. It's an inscribed angle. Okay. All right, here we have BC is 12. The whole length is 12. Okay. FE is 5 more than DE. So DE is X. This is X plus 5. The whole thing was 12. Oops, the whole thing is 12 right here. So FE is, oh, its whole length. Okay, BC is 12. Okay. This makes it 12 minus y. FE is 5 more then DE, x and x plus 5, then FE is what? Okay. Oh, in the diagram below, chord DF bisects chord BC. Oh, bisects, that's the key. It bisects BC. So that means it splits in half. Because BC is 12, then each of these is 6. That's why. Okay, so I have 6 times 6 equals x times x plus 5. Gotta read all the directions. Okay, so I have 36 here equals x squared plus 5x. This is a quadratic, so the first thing I do with all quadratics is set equal to 0. And now it's a plus 5x minus 36. And now I can factor that into x plus 9 and x minus 4. And so x equals negative 9 or x equals 4. Well, obviously we can't have a negative length, so the answer has to be 4. Now, if this is a calculator problem, I could just type this into my graphing calculator, x squared plus 5x. I'll show it to you since we're doing it over. I've already got it in our assignments, but I'll do it here for those that can't factor. That was algebra 1 factoring. Okay, so we go to y equals, it was x squared plus 5x minus 35. And then we wanted the other one 0. We're across the x-axis. Second calc intersect number 5. And we only want the positive answer because the answers can't be negative in the real world. So that's 1, 2, 3, 4. But if you want to check that, I'd hit enter, enter. My guess, I'm going to put it closer to this one, which already is closer. And you see you get 3.92. So I must have had some off. It must have been, oh, it's not 35, it's 36. That's why. Okay, see, I got that because I already factored, so I knew what the answer was. So second calc, number 5. First curve, second curve, guess, and there you see x equals 4. Okay, so that's how you can plug in the graphing calculator and do it if you're given a graphing calculator on that. Last one, determine and state in terms of pi the area of the sector. So now there's area of the sector. So area is the key, pi r squared, area of the sector, x over 360 times pi r squared. That intercepts a 40-degree arc. The radius of 4.5. So 40 degrees, pi r squared. For the zeros cancel, 4 over 36 cancel down to 1/9. Okay, in terms of pi, that means you have to leave pi in the answer. So when I do 4.5 squared, that's 20.25 over 9 pi. Now I cannot leave a decimal in a fraction. Okay, so I need to put that in a graphing calculator. Well, I'll do it by hand first, just in case there wasn't a graphing calculator to use. Well, it's 20 and 1/4. I need to change that to an improper fraction, which is 81/4. So now I have 81/4 divided by 9, which means 81/4 times division gets changed to multiplication by the reciprocal, and 9 cancels with 81 9 times, so it's 9/4 pi is my answer. That's what it is in terms of pi, and then units squared, whatever it happened to be. Then I'll tell you, so it'll be 9 pi over 4. You could also plug that in a graphing calculator and do 4.5 squared divided by 9, hit math, enter, enter, and that will give you the 9/4. Anyway, that's how you do it by hand if they didn't have a calculator for you to do. I think that's it. Finally, we finished. 60 minutes almost.